So, till now we have seen how a context-free grammar can be um, simplified and how a language can be defined for a context-free grammar. All those things we have seen. Then in here we are going to learn about how to design a context-free grammar. We have learned about the finite automata and its design, regular expression and its design. Like that, we have learned. Similarly, the context-free grammar, we have learned about the some concepts of context-free grammar. Now you need to design a context-free grammar based on the language or based on the automata or based on the regular expression that is given in the question. So we can start with a simple example like design a context-free grammar for a given language. L of g is equal to a raised to I, b raised to I, such that I is greater than or equal to 0. So this is the language which will be given in your question. You have to generate the context-free grammar. So here what is the minimum string? Here a language is defined and the minimum string of this language is, as you all know, if I, here it is said I is greater than or equal to 0. So if I is equal to 0 means the language will be having minimum string as epsilon. If I is equal to 1 means it will be having AB. I is equal to 2 means AA, BB, like that it goes on, isn't it? So this set of strings need to be accepted or can need to be derived from the grammar that you are going to design. So how you will be able to design the grammar? So as we have learned, it will be having a start symbol S. It will be having some start symbol will be there. And the right hand side should be like epsilon is an element of the language. So epsilon will be one of the production of S. And then the terminals will be the elements that is forming the string. So A and B will be considered to be as the terminals. If a single A is there means single B also. A single A followed with a single B. Two A's means two B's will be there like that. So based on the number of A's, number of B's also will be there. That is the thing we can conclude from this language. So you can write it like A, S, B, which means that if I start with epsilon is getting accepted, if I start with A, S, B, and if I need to derive the string A, B, what you have to do? You have to apply epsilon over here and you will be getting the string as AB. Now if I need to get A, B, B, then S derives A, S, B. Again, this S will be replaced with A, S, B alone. And S gives epsilon, you will be getting A, B, B. So in this way, you will be able to derive the strings. You will be able to derive the string from the grammar. Okay, so this is so the grammar generated for this language will be this one. Then let's see another one example. If in previous case it was like L of g is defined as a raised to I, b raised to y, such that I is greater than or equal to 0. Now next example we can see if I is greater than 0. Here the minimum string of the language will be not epsilon, it will be AB. Okay, so followed and other strings will be like A, B, B. If there is 3A means it should have 3 B's also. So what is the modification that need to be, or how the grammar can be generated? So here AB is a minimum string. So S gives, AB you can give. And the other things, equal number of A's and equal number of B's, like that if it is required means that too A followed with B. All A's followed with equal number of B's, then you have to insert the right hand side as A, S, B. Okay, so I understand the difference. Here the minimum string is AB, so instead of S gives epsilon, I have inserted S gives AB. If the minimum string is epsilon, then you have to insert that epsilon in the epsilon as one of the protection. So this is the resulting grammar or the generated grammar for the given language. So we can see one more another one example. Let the language be defined. Let the language be like L of G is equal to A raised to I, B raised to I, C raised to J, D raised to J, such that I comma J greater than or equal to 0. So from this language, what you can see, equal number of A's and B's will be there, then equal number of C and D. So two rules are there, isn't it? For A and B, it should be equal. C and D, the count should be equal. So in order to represent these two rules, I am defining two non-terminals for that, A, B and C, D. So S gives, for A and B, I make it as X. CD, in order to define for CD, you can define it as Y. So S will be like XY. Now what is this X? X is having equal number of A's and B's, and where I value can be equal to 0 also, which means AB, it can, if I value equal to 0 means A and B, 0 occurrence of A and B, which means in that place you can substitute epsilon. So X gives epsilon is there. Then if I is greater than 0, that is if it is 1 means you will be having AB, isn't it? Then 2 means A, B, B. So equal number of A's followed by, number of A's and B's will be same, and occurrence of A, B will be followed with the occurrence of A, after the occurrence of A. So you can write as written in the previous example, A, X, B. Similarly, you can write for CD also, that is for CD only I have used this non-terminal Y. So Y again, I and J can also take the value as 0. So it is epsilon, and in order to see equal number of C and D, you can insert like this, C, Y, D. Okay, so this is the grammar generated. So when you write for the exam, you can write it, you have to define the tuples for each grammar. G is equal to VT, PS, and P is defined this set of protections. V will be the variables, which is S, X, Y. T will be terminals. Here it is A, B, C, D. And P will be the, S will be the start symbol. Here S is S itself. Okay, start symbol. Now, just try for I comma j greater than 0. Okay, that is same language, only difference is I comma j, instead of greater than or equal to 0, you have to instead of I comma j greater than or equal to 0, you have to try for I comma j greater than 0. So what is the difference? We have seen in the previous example itself, that is instead of epsilon you have to include. For x gives epsilon, the grammar can be written as s gives xy, and x gives, instead of epsilon you have to write ab, axb, and instead of epsilon in y you have to write it as cd, cyd. So this will be the resulting grammar. Okay. Write one more example, that is design a context-free grammar for the set of all strings which are palindromes over an alphabet sigma is equal to set a comma b. So the terminals will be formed from this input alphabets. Okay, so we have to define a context-free grammar or generate a context-free grammar. Generate a context-free grammar which will be accepting the strings generated from these terminals A and B, and those strings, they are palindrome, that we have to prove. So what are the strings for the language that can be formed to form that can be taken as a palindrome using these input alphabets? Epsilon can be taken as a minimum string, then A also can be treated as a minimum string, B also can be taken, then A, B, A, B, like that it goes on, isn't it? So if the here you can see that the minimum string is epsilon, A and B. So for the grammar also you can take it as S gives epsilon, A, B, they are the minimum strings. Now to monitor this, that is equal number of A's and not equal number of A's, from left as well as the right, it reads the same input symbol, isn't it? To monitor that, you have to insert. That is, if I am reading A from left, means it should end with A in right. Okay, if I read B from left, means it should end with B in right. So this can be repeated any number of times. So for that, I include this yes inside the in between this A and B. Now you see whether you are able to generate these strings. So whether you are able to generate ABA, you can check. So using ASA. Okay. Now S gives B, one production is there. So you can take A, B, A. Okay. So you also will be able to check whether you are able to derive this string also. So how you can derive? As first you have to use A. So A S A. Then again ASA you can use. So A S A. Then third symbol is B, isn't it? So you have to use which production? BSB you have to use. A BSB A. Then lastly, using epsilon, A, B, B, A. Okay, so this is the grammar which can be generated to satisfy the string of palindromes. Now, the same grammar same grammar can be modified such that it accepts only odd number of strings. So, in order to make the language, or in order to make the grammar accept only odd strings, in such case, what you have to do, if it has to accept only the odd one, means you have to remove this epsilon from the grammar. Why? Because epsilon is epsilon will not be the minimum string in such a language. If the question is asked like, it need to accept the string of palindromes and the length of the string should be odd. If a question is given like that, in such cases, epsilon will not be the element of the language. A, B, element of the language will be L is equal to A, B, A, B, A, B, A, B, like that it goes on. So, in order to satisfy this set of languages alone, what you have to do, you have to remove this epsilon from the grammar. So, this is the next example. Okay, that is, first you have done palindromes, which will be accepting set of strings, set of all strings that are palindromes formed from the alphabet A and B. So for that you can write this grammar. And if an additional condition is also given, like it should accept only the odd numbered string, then the grammar will be written as S gives A, B, ASA, BSB. And similarly, another third question will be like, accept the set of all strings forming palindromes and is even numbered. So even numbered means in the language which all strings will be there for even numbered. For even numbered language will be having epsilon can be taken as a minimum string. Whether A will be an element of the language, no, it is odd numbered. B also will not be the element of the language. So A and B will not be there. Then using ASA and BSB, you will be able to read the same symbol from left as well as from the right. Sorry. L is equal to epsilon will be an element. A will not be an element. So AA will be an element because it is even numbered. BB can be taken as even number. AAB AAB BAA. This can be also taken as an even numbered string. So like that it will be checking. So for this set of language, the grammar can be minimum string epsilon it can take. Then A, S, A to for reading the same input A from left and right. Then B, S, B. So this will be the resulting grammar to accept a set of all even numbered strings that are palindromes. Okay. Same concept you can do for another one thing, that is L is equal to W raised to R such that W is binary. What is the solution you will be getting, or what is the grammar that can be generated for this language? W is binary, which means sigma is set 0, 1. So W will be formed using this zeros and ones. So the minimum string will be like, L will be having epsilon you can take. Then what will be the minimum string? If I am taking 0 means the reverse will also be 0. If I am taking 1 means the reverse WR is 1. Then if W is taken as 0, 1, then the reverse will be like 1, 0. Okay, so this is W. This one will be taken as W reverse. So this is the same set of strings that we were getting in the previous example also. Only difference is instead of input symbol 0 1, there we have used AB. So how you can modify, how you can write the grammar for this language? Yes, gives epsilon you can take, and then if I read an input symbol 0 from left means it should be right at the right also. So for that 0 S 0, 1 S 1. Okay, so here also what happens, it will be accepting which numbered strings, even numbered strings. And if there is additional question like it should accept odd numbered means, how the grammar can be changed, it can be changed like adding two more productions 0 and 1. So just go through these examples and see whether you are able to understand the concept of generating the context free grammar.